Good morning to all. So today we are going to discuss our unit 2 run of like a stage discharges relationship flow measurement. So how the flow are measured. So this topic is correlated with the Earth's outcome of summarize the concept of well hydraulic structures. Then the correlated with the program outcome 1, program outcome 7 and then program specific outcome 1. So rainfall has an effect on stream flow and hydraulics tends to measure the relationship between rainfall and stream flow. The aim of measuring stream flow is mainly in establishing a stage discharge relationship. So the definition rainfall result in infiltration I, evaporation E and evaporation time ET, intercepted and depression storage, surface flow Q. So the Q and QG and interflow goes to stream. So the stream will be flow and the channel and basin watershed. Okay, so the watershed management and water surface elevation we can see. So the stage measurement are mainly made with the gauges. So the component of the flow, rainfall, then overland flow and interflow, then groundwater, then channel flow in the stream. So the stage discharge relationship, the simultaneous measurement of stage and discharge provide a calibration graph known as stage discharge relation or rating curve. The stage height of stream level measured from an arbitrary datum. The depth measured from the bottom of the channel. So the datum can also be the mean sea level. A plot of stage versus discharge is made to obtain a rating curve. The stage discharge relationship, the method, non-recording stage gauge like stop, wire, string, crest stop. The recording stream gauge, flat type, then digital gauge. The manual gauge, non-recording stages, then sanctioned stop gauges, a series of posts, each overlapping. The height above a certain datum is measured. The stage is usually related to height above mean sea level, MSL level. So see the water surface where the inclined gauges, the gauge is inclined to a certain angle to measure water stage. In some cases, it may be impossible to have stage gauges. So the following arrangement can be used. So see the bridges we have to make, then strings will be formed. So it will be flow in a frequent manner. So the stage measurement, the certain datum level is on the bridge and a string having a weight electrically connected in lowered to the water surface to get the depth of the water surface. The stage measurement can be inaccurate if there is coursing. So the rules guiding location of gauges. The gauge should not be located in rivers with sourcing characteristics. The location should steer clear of river bend because the water surface is inclined and there is turbulence making the stage measurement inconsistent. The upstream of the natural control, example a rapid should be used not downstream. So see the calm area, this is the rapid area. So because here the water is come without any collapse, but here it will be rapidly flow in this downstream area. Why? Because here the slope is occur. So the rules guiding location of gauges, a uniform channel help good stage measurement, whereas the irregular cross section should be avoided. So it is okay, but it is avoid this irregular section due to we cannot predict the exact area the flow stream in this stage. So the recording gauge, so they have advantages over the manual one. Why? Because the plot gauge, the plot movement fluctuate with change in stage, and this is recorded by a chart. So in hydraulic measurement, both the big and low flow are measured within the chart. So the flat gauge, so the chart will be record and flat will be measured like this. This is the stage wise. Here we can calculate the flow of water. Whereas the digital recorders, they have clocks and used when, for example, hourly measurements are designed usually where stage do not increase and decreases steeply. The record should be placed at a height more than the expected peak stage. To know the maximum stage expected, an ordinary gauge can be used for some times. So the crest gauge, they only measure peak flow. It is a cylindrical tube sealed below with only a few holes to allow the water to enter the tube. A ground cork fixed in the tube floats up and it held by surface tension. When stage increases, it stays at maximum stage until the reading is taken and let loose. So the crest gauge. So see from here, the gauge based we can measure the flow. So the discharge measurement. So the current meter, it has a propeller which is rotated when water hits it and is connected to magnet which accurate records when the propeller rotates. So the velocity of water increases the propeller rotation. So the current meter. So see the meter based, okay, it will be a rotated based we can measure. So the number of rotation are measured and correlated to velocity using the formula. So V is equal to A plus B into N, where N is the rotation of the propeller, revolution per second, RPS. So A and B are coefficient determined by calibration in an experimental flow. So the current meter, so see the velocity based, so the propeller rotation in the nth value. So this area, this will be rotated based on the velocity in, so B based 1, then surface velocity up to 0.6 d, then average velocity we can taken from here. So this is total enter d. So the considering the velocity profile with the depth, average value of velocity can be obtained at 0.6 of the depth, that is V is equal to average velocity is at about 0.6 d. An alternative of using the 0.6 d velocity is to take 0.2 and 0.8 velocities and obtain the averages. The latter method is more accurate, but in a shallow cross section, the velocity at 0.2 d may be difficult to measure, so use a single value at 0.6 d. The discharge measurement, velocity minus area into area station method, Q is equal to V average into A, where V average is equal to 0.6 for shallow stream, where depth is less than 3 meter. So V average is equal to V 0.8 plus V 0.2 divided by 2 for moderate stream, whereas the deep stream like a flood flow is V average is equal to C into V 0. C into V 0.5, where velocity measurement, velocity of flow VA average is equal to C into VF, current meter V average is equal to A plus B into N, where Q is equal to summation of QI is equal to summation of VI into AI. Determination of discharge through the velocity like a V 0.2 d into V into 0.08 d. So the average discharge is equal to V into area of segment. So the moving boat method for large rivers, chemical gauge, concentration of chemical tracker, ultrasonic, indirect method like measured flow depth Y to get Q by flow measured structure such as wears, orifices, etc. So the slope area method such as Chai, Manning, Huygens. So the measurement of discharge, uh, first divide the cross section of the stream into vertical sections such that no section carries more than 10% of the total flow. Take sounding to determine various depth. The sections are of a known width and so their discharge can be calculated if the velocities are taken along the 0.2 d and 0.8 d or maybe 0.6 d along. The discharge measurement like flow in one segment, Q is equal to average velocities into area of segment. The area of each segment can be calculated using the trapezoidal formula. So the total discharge Q is equal to average velocity into area of segment. Q is equal to summation of Qi is equal to summation of Vi into Ai. So the discharge measurement using float. Any floatable substance, example a tennis ball, is placed at a point and the time t it takes it to move a known distance is noted. So d divided by t gives the average surface velocity of the water. The surface velocity is equal to 1.2 average velocity V, that is Vs is equal to 1.2 V and V is equal to 0.8 Vs. The cross-sectional area of flow is then multiplied by the average velocity to get the flow rate. So see the rating curvature. So the essence of the rating curve is that when the curve is established for a particular stream, the subsequent determination of the discharge are merely obtained by dipping a measuring stick to measure the stage. Discharge is then read from the rating curve. The rating curve should be checked from time to time for accurate measurement. So see the rating graph, the depth based the stage will be different. From here the curvature will be heightened, like datum will be formed. So whereas the stage will be increased, the rating curve occur the frequently it will be increased and it will be maybe stagnant like a discharge based. The rating curve type, the simple rating curve on arithmetic paper like parabolic curve or q is equal to a into y minus y naught into c. Where on logarithmic paper, the straight line as log q is equal to log a plus c into log y minus y naught. Where second, see the extension of rating curve used logarithmic method to get qp. So these are the reference material. Thank you.